You gonna try it on?
Really?
Yeah, gonna try it on?
Okay.
You get a chance to try on a real, honest to God, Apollo helmet bubble.
Dude. Oh, it smells right.
Hey everybody, Adam Savage at Global Effects with Chris Gilman in his Palace to Spacesuits. And this is the workbench of the man himself. Dude, I look down at this and I am thrilled, and I'd like the audience to start to understand just how exciting. What's going on here? What are these pieces?
Well, as I've said before, we try to make stuff as accurate as we can.
Yeah.
And while I don't really need to do it for the film, I sometimes can't control my geekdom.
You can't resist the challenge.
I can't.
Because once you have the knowledge, you want it in the piece, right?
Well, one of my first bosses pointed out something to me, and this is really important for anybody who makes things. There is nothing that is truly hard or easy. There are things that are just less or more familiar. And if you think of things as that, as less or more familiar, it takes the pressure, the onus off of it feeling like, oh my God, this is gonna be hard, or oh, it's gonna be easy. Because I grew up around a machine shop, this was familiar.
Yeah, right, okay.
Right? And
the pieces and the topologies.
Now, I am not a machinist.
Yeah.
I am not a machinist. I've seen machinists that I would be embarrassed to even use that word.
Yeah.
But, so, I decided that I really, really wanted to make replica Apollo fittings for the gas fittings. Well, then we got a call from somebody at NASA asking if we could make training fittings. Now, when you engineer a part, you engineer it not only for the function, but you engineer it for the environment and what it has to do in that environment and the materials around it. So in a pure oxygen environment, you have to use specific seals, specific lubricants, specific materials. But if you're going to put them in a pool with chlorine, those aren't necessarily the materials that you should use.
Sure, right.
And the company Airlock, who makes the real ones, this is the same design that's been around since the early 60s.
Yeah.
They don't make training fittings. They make flight qualified fittings.
And asking them to shift to a different material set is just, that's not going to work for their pipeline. They don't do that.
So they asked us. So this is a real oxygen plenum.
This is a real NASA?
This is a real original Apollo plenum. So's this red one. So you would have the red one below the blue one.
Right.
So if we were on the suit, this would be here.
And these are part of the air movement system, keeping the astronauts cool, keeping them breathing, keeping them healthy.
And there would be plumbing. It would go to different places. Yeah. And this is a diverter valve. So you can divert the amount of flow from the helmet to the rest of the body.
That's what that little dial is.
That's exactly.
Amazing.
So let's look at our replica.
Oh, there's the dial. That's the one I mean.
Yeah.
So that's a diverter valve for changing the direction of airflow.
And there's a little diverter inside, a little flap that moves.
Okay, I'm looking at this part. Can you tell me, is that a real NASA coupler there?
Yes, exactly. This is a real top. Here's its bottom. And so here's our real top. And here is an elbow.
What a sound.
And then when you release it.
Crazy.
Here is a replica of one of the other, there's like 4 different versions of these things. When I first started looking at them, I thought, oh, okay, there's that. And then as I got into it, I realized, oh, wait a minute, there's a left-handed, a right-handed, a this or that, So here's another one. And you have so this is kind of cool. They have a safety lock.
Yeah.
So that even if you pull up on these guys, you can't rotate them.
Yeah.
You have to move that, then you rotate this and do that,
and then it pops out. And it's a positive pop out. It's not like you have to yank on it.
And how that works is there's a piece inside you can see that is a water block. And there's 2 of those. This is one of them.
Okay.
And what's cool is these ball bearings that would fit in here. It's a tapered hole, so the ball can't go any further inward.
Right.
And you'll notice that our elbow has a groove here and a groove here. And what happens is when you put this in, the bottom groove lines up with those balls in there, and when this gets pushed down, those balls are forced inward and they engage this groove. So that block is now mechanically tied to this. So when it opens, it opens the airflow. And when you get all the way to the bottom, you push down these 3 plungers and it locks. And when it locks, these balls pop out into this groove. And now this is locked in.
Gosh.
Now when you lift up on these tabs and rotate, you'll see these pop back out. There's little plastic posts in here underneath these that when the 2 surfaces line up, they pop up and they hold this in the open position. But when you pull this out, it's still engaged with the balls in the block. So it forces it to get sealed again. So the suit is absolutely sealed. All of this engineered in this little tiny package.
Unbelievable. Now, how many different parts are there? Is it this many parts?
Well, almost. We have...
I love your sorting system, by the way. Everything has a picture of it on the top. That is really, really beautiful. I want to say when I replicated one of these, Ryan Nagata had a wax casting that I measured off of. And I started going through territory you're deeply familiar with. But one of the things I found so beautiful was every time you got close to a measurement, you could see you were close to like a whole fraction. Like 1.25 inches or 1.5 or 3/16, or, you know, the angles were all in whole numbers. And what it felt like to me was a NASA engineer blowing a kiss across the decades saying, yes, you know what the measurements are. If you have the real one, you will know what my intention was.
For the most part. But interestingly, there are a number of measurements in this that are, because I fell prey to that. I fell prey to well, it's probably going to be close to.
Right.
And then you find out, no, it's not.
I was wrong.
No, well, in some things you're absolutely right.
Okay.
In other things, it's just enough off that if you make that assumption, it doesn't work, because a couple thousandths of an inch means it doesn't work.
Oh, man.
Yeah. Now, here's a fun one. This is a fitting that's up here. It's blue.
Yep.
And you see there's a big hole. All these other fittings are blocked.
Right.
Well, this is because a cool suit is supposed to plug into the back of this. Well, we just happen to have a real Apollo cool suit connector.
Is this
now the hoses are kind of crispy, but that's a real one.
Isn't
that cool, clear?
That is
Isn't that
so
awesome?
Cool.
So my friend Dennis goes, well, if we had to make this, how would you make that? And I would do metal. I'd do a metal core, and then metal cores that fit into it, and then I'd make a mold the outside, and I would have the silicone have enough shoulder on it to hold the cores, and I'd pour it and then slide the cores out.
Wow.
But let's see, we take this. And we fit it into the back. So this would be in the inside of the suit. You'll see it has a little pin there for alignment.
Yeah.
And you have to unlock it first. You got to be smarter than the fitting, I guess, sometimes. So we plug it in and then we lock it. Now with this in the inside, you see your suit is sealed because the O-ring is in the outside and the back.
Right.
Then from your backpack, you have this connector. Now what's really awesome about this is there's an inner channel and an outer channel. One is water in, one is water out.
Oh my God.
And they both nest inside of each other.
What?
And latch.
That sound.
They really are a fidget toy. I want to work on these.
It's
I
like
just
a
want to play with them.
ASMR video
really,
is something that we got to do.
So now you have 2 chambers, 2 paths for cooling.
There's water in and water out.
Water out. Now, some engineer at NASA decided they needed to
bandsaw
it off.
Oh my God.
All right. So now we'll pop this out, and you see it snaps out.
Yeah.
And then we'll take out the back one. Now, what if you're not wearing a cool suit? You have a plug.
Oh, that comes from the back of the suit.
And we put the plug in, and then we lock it.
Now, why wouldn't you have a cool suit?
Apollo 8 never landed on the moon. In fact, it was the first manned mission to the moon, and they just orbited the moon in the command module.
But they're
didn't
wearing
pressure suits, but they're not wearing cool suits.
Got it. That makes total sense.
And if you've been at the Smithsonian, you've seen Neil's suit.
Yeah.
That plug is in that suit. So you see, this one here. Well, you notice this is faded a little bit.
Yeah.
And you were looking at that earlier. That particular one just happens to be Frank Borman's from Apollo 8.
No.
That's the actual fitting that was in Frank Borman's suit on the very first manned mission.
I just want to hold it like this.
Pretty cool, huh?
It really is. I mean, there's another thing I've detected when handling some real NASA hardware is when I slide it, like there's the measurements on the blueprint, and then there's the measurements that a machinist understands about how metal moves and what real tolerances are. And I can feel in those Apollo hardwares some intense institutional knowledge about slip fits and incredible precision.
Couple of thousands here or there makes a difference between a click and a clunk.
Yeah. This is so inspiring. So how often are you maintaining parts like this at this fidelity?
This is really the first time we've gotten to this level. I mean, we've made replica tools. Like, okay, so here's a replica of the early Apollo hammer.
One of my favorites.
Well, almost every replica I've seen is wrong.
How
it's
so?
wrong because they make the handle round.
Right.
The handle is
Oh,
oval.
yes, it's oblong with flat sides.
And it's hollow.
Right.
And it only has knurling on the radiuses, not on the flats, which is really hard to do because they're not the same center. And you've knurled stuff.
Yeah.
They have this spring-loaded catch so they can put on an extension handle.
Right.
The heads are also steel. Now, this one got some chemical burn on it, but they're tool steel, are coated in aluminum, vacuum coated in aluminum, with it cleared off the tip and the back. This is right off the blueprint of the original hammer. And what's even cooler is the mil spec number. Now, a mil spec is where they give a particular code number to a screw or to a part.
Yeah.
That's original mil spec roll pin, original roll spec roll pins in there, and original mil spec springs. The company in New York still makes the same spring.
No.
Yeah. So that level of when you can do that.
It's not only a hollow oval, it's freaking tapered.
Yes. It's crazy. And there was something to do with, so the blueprint talked about some sort of electroforming, magneforming this. So magnetic forming, and I don't quite understand what they did.
Fascinating.
Yeah.
Oh, the moon tools are among my favorite NASA pieces.
I love the rake. The rake is so cool. So we had to make these stainless steel cages.
Yes.
Now, if you look, they're not a standard. These are just being fit right now.
Right.
So these are not. There's a radius here, a radius here, and a radius here.
And they're all different. And they're all different on each.
And they're all
one.
tapered. So how do you do that? And you have to make this side and the other side the same.
Right. So that there's at least two of each one. That's one efficiency you get. But this big block, does this have to do?
Bring the big block over. The big block.
What's going on with that?
So I love 3D
That's
printing.
3D printed.
It's 3D printed tool. So there are the numbers of each
Amazing.
coil, and it uses to bend them. And then I can use this to give them kind of a final form. Now they still need some tweaking because you always have spring back.
Right, because it's stainless, am I right?
It's stainless steel.
Yeah.
But I was able to use this so that I could replicate.
Tremendous template. That's brilliant. This is just what 3D printing should be. It's just like one of the best uses I've seen.
Thanks.
Oh, that's great.
And then there's another tool over there, the oval one. Okay, so this is another one that's a little simpler. I printed this one so that I could get the form, and you can see I use a little bit. We call the BFI method. It's brute force and ignorance.
Fair, yeah. I'm very familiar with that.
I use a little too much brute force.
Yeah.
But this is to make this piece.
Oh, right.
Right?
And
So
then because you have a template for both, they're going to match well.
Absolutely. And then I also need to make sure the holes are drilled.
Right.
So I have all the holes lined up so I can clamp this in the middle to hold everything flat, and then I can use this to make sure that because I don't really need to be within a few thousandths.
Right.
And your eye is really good at thousands. So this is how we've been making some of the tools, and we've now replicated the contingency sampling tool, the heavy hammer, the light hammer, the wrist checklists, tether hooks.
I mean, on the one hand, you're right, it's unnecessary to do this for movie costumes, but I'll bet when you have given an actor the full Monty with all this stuff that they really appreciate it. It informs the role, it informs the character, and that's ultimately what you're doing here.
Well, one of my pet peeves when they would shoot Apollo stuff is they would always put the helmet in and rotate it to lock it. And that's not how they lock. Right? And they even did that on First Man. I was like, no, because we had real working neck rings.
Right. They could
real working neck rings. Now, the one thing we haven't had, which they've had to fake, is plugging the thing in and sort of locking the fitting.
Right.
But the cool thing is with these, they are all designed for one-hand operation. They really are designed
for an astronaut's glove.
I can look at you, find the fitting, plug it in,
right,
and then I can reach down and pull it out, and I don't need to see what I'm doing.
And that's really important for the performance, I'll bet.
Yeah.
Chris, this is so amazing.
So would you like to see some Apollo hardware?
Yes, I would.
Well, we have a table over here,
right.
Apollo hardware. So this is a little bit of a history of some of the hardware that we've done.
So pretty.
Now, no, this is the real one.
This is a real.
Yeah. Yeah, it's a real bubble.
Man.
Yeah, it's Apollo. Oh. You gonna try it on?
Really?
Yeah, you try it on?
Okay.
You get a chance to try on a real, honest to God, Apollo helmet bubble.
Dude. Oh, it smells right. Incredible. Incredible how little space they had. I mean, it is really an efficient size.
Yep, yep.
Oh, man. You can hear it, right? Yeah.
Okay, what is the, what do
All
we,
right. Okay,
we
so
can
we'll
spend
start over
hours,
here.
but what is this?
So this is just a fiberglass LEVA, which stands for Lunar Extravehicular Activity.
And this is what the actual levers look like?
Sort of.
Okay.
This is our early one.
Yeah.
And I'm using it, so we have behind us our heritage suits. So these are some of the first suits we ever built.
Okay.
So this was Carrie Elway's suit from Earth to the Moon.
You know, I realize I recognize this because I think I bought a vacuform of
You might have,
this
yeah,
off
yeah,
of your
yeah.
eBay store.
But I have blueprints now, and we're upgrading these two to the correct.
Oh,
because this is not
amazing.
quite correct. This is one of our replica, the real bubble, but our replica pad and our replica ring. As we just said, this is a real one. This is one of our simple, what we call a bayonet style release. Basically, you just line up the grooves, and the ring comes out because little spring plungers in here.
Okay.
Right. And you know what an Ortman wire ring is?
I don't.
So an Ortman joint or an Ortman wire is where you have two channels, right? And instead of putting a ball in, you run a wire. You run a cable through that, and now the cable won't allow those things to come apart.
Right.
So I had a real brain fart when I made these, and the bearing slot I made way too tiny, and I thought, I don't know how I'm going to redo these. And then I remembered, oh, Ortman wire ring. So what keeps these together and allows them to rotate is a wire. It's a Teflon-coated wire that I've threaded in that goes all the way around between what should have been ball bearings, but the machining wasn't accurate enough and the balls were too small, so I bailed myself out.
Amazing.
Yeah.
And so this is like even with the hardware, you have A grades and B grades.
Right, and so this is one of our A grade ones. Now this is set up like an Apollo 11 one, and you'll see it's blue and red, and that's because the early rings were blue, and as they started working, doing the moon simulations, they realized with the amount of effort that they were putting in, they were burning more oxygen than they were getting. So they needed a higher oxygen flow to the suit. Well, this is the plenum. You notice we also have a little silicone seal.
Yeah, that's
we
the
put
thing
in.
that connects up to the back of the pad here.
Right. Well, if you look at their real helmet,
It's small.
you'll see that it's part of the ring.
Right.
Whereas this part bolts in.
It's integral.
Right. And so they couldn't enlarge this because it's part of this. This one, they could just unbolt the smaller one and bolt in a bigger one. So they ended up making the new ones with a red ring.
So the blue and red is a moniker of what it fits.
Exactly.
Gotcha.
And because the Apollo 11 suits had already had their neck rings bonded in, they only changed the outside ring to red. So this has the spring-loaded position, which would be there.
Right.
And then the full lock position, which is there. So if we put it in the spring-loaded position, you can drop the helmet in.
The real NASA helmet will
real
fit
one.
in your manufactured neck ring. Oh, that's
And
gorgeous.
we can close it.
Oh, wow.
Now, helmets are helmets, but we have something else here that you might be interested in.
That's not a real glove, is it?
Certainly not one of my replicas. That's a real
What the?
EVA glove.
Yeah.
Now,
with the
that belongs to
sticky
Dennis, my friend
palm.
Dennis. And he said you're welcome to try it out.
Oh, man. Oh, wow. I am learning so much.
Is that cool?
Yes, because I like my fingers are right here, right out at the end. Oh, man. Thank you.
Ever wondered what this is?
Is it part of the tightening system for the palm?
And so you can get to the tightening strap because so this cover goes over the rubber IVA glove, but it doesn't go over it when they're on mission because it's too complex. It's all glued and fitted.
Right.
So this is actually a separate set of gloves in the lunar module. But the rubber gloves have what is known as a palm bar. And that palm bar goes across the palm of the hand because your hand is oval.
Yeah.
And if you need to put pressure on the glove because it wants to distend round again, that palm bar helps keep it oval.
It keeps the
problem
envelope
is-
around your hand as tight as possible.
Exactly. But the problem is it's going to bind into the sides of your hand, and think how uncomfortable that's going to be.
Right.
So this strap
Allows you
is
to
so you
adjust
can
that.
loosen it.
Oh man.
And then of course they have a thermal cover. Goes over. Now, this is Chromel R.
Which is like one of the most expensive materials made at the time it was made. Am I right about that? Oh, no way.
So I managed to score a piece of Chromel R.
Dude, this is, so do you plan to make yourself a pair of gloves using the real Chromel?
I've been very tempted, yes. Yes.
I'll bet.
So Chromel R, when I first heard about Chromel R, I was told it was woven stainless steel. And if you look, it's really like almost fabric, like yarn. Well, what it is like literally hair-like threads of metal that have been made into a yarn, and then the yarn is woven into a fabric. It's not like a piece of screen where one wire is the thread. I just talked to a guy the other day who helped fund the restoration of Neil's suit.
Oh, yeah.
And he said that the Smithsonian researched it and found that the first ones were woven stainless steel, and then they changed to the Chromel R. And so what I always heard, the Chromel R was stainless steel.
Yeah.
But Chromel R is actually 80% nickel, 20% copper. So it's not stainless, it's an alloy. And I managed to score this. I've never, ever seen a piece that wasn't on a glove or a boot.
Yeah,
And I managed to score this piece. Okay, so we get all this other stuff out of the way. We have one of our replica Mercury neck rings, which I had a genius machinist here do for me on our old lathe, and it shows you that a good machinist doesn't, you're good. You go right to there, right?
Oh, right to there.
And then the helmet ring comes out.
Amazing.
And he machined this on our lathe, and it shows you that a really good machinist can work miracles with equipment. That
really can.
Yeah, they're beautiful.
That's amazing. Oh, so pretty.
And then,
All right.
now you'll notice, remember I talked about older materials yellow?
Yeah. The fiberglass.
That's a real one.
This is a real one.
Yes.
Oh, no way.
So our replicas were actually molded off of this exact helmet that belongs to my friend Dennis.
Wow.
Except for the neck ring, which is a replica.
It looks absolutely perfect.
And it fits perfect.
Look at these little plenums.
Yeah, that's how. So this is pretty cool. So we'll unlock this, take this off. And you notice the vents. That's because there's hollow chambers that run up.
Oh, for the blowing bar at the top.
And the air comes through that slot. And in the ring, there's this inner chamber, and there's supposed to be a little thin blade of fiberglass in that groove. And that little thin blade of fiberglass
it routes the
overlaps this inner step here to guide the oxygen through.
Crazy.
And then our latch has a safety, which you undo the safety.
Yep.
You push down this, and then the bailer bar comes up. Now, the bailer bar, like on an Aces, you don't grab the bailer bar to close the visor. If you do, it tries to articulate the visor down into the helmet. But that has a complex gearbox in the ear, whereas this has this clever little cam system.
Right.
And you'll see that how it moves out away from the seal
and then
rotates up. Wow. And you were talking about the fineness of machining. Operate that, and you'll feel the difference between the replica and. Is that beautiful?
Yeah. I mean,
everything is just so silky smooth.
There's nothing out of place in any way. Oh, crazy.
You want to try on a real Gemini helmet?
Why, yes, I. Even less space. Oh, man. I mean, I think my head is a little big for this issue.
Yeah. But pretty cool.
Oh, my goodness. All right, I'm just going to need a few minutes to myself.